Thank you, Professor. It is an honor for me to introduce our chief guest, Dr. Shajulin Benedict, IEEE Senior Member, Indian Institute of Information Technology, Kottayam, Kerala, India. He graduated in 2001 from Manonmaniam Surendranath University, India, with distinction. In 2004, he received ME degree in Digital Communication and Computer Networking from AKCE Anna University, Chennai. He is the university's second rank holder for his master's. He did his PhD degree in the area of grid scheduling under Anna University, Chennai. He was affiliated towards the same group and published more papers in international journals. After his PhD award, he joined a research team in Germany to pursue postdoctorate under the guidance of Professor Gendet. He served as professor at SKCCE Research Center of Anna University, Chennai. Later, he visited TUM Germany for teaching and cloud computing as guest professor of TUM Germany. Now, he works at the Indian Institute of Information Technology, Kottayam, Kerala, India, an institute of national importance of India. He serves as director, PI, representative officer of AIC IIT Kottayam for nourishing young entrepreneurs of India. His research interests include cloud grid scheduling, performance analysis of parallel applications, cloud computing, IoT, blockchain, parallel compilers, and so forth. I'm honored and privileged to welcome our chief guest, Dr. Shajulin Benedict, sir, to deliver the keynote address.
Thank you so much for introducing me. Let me share the screen. It looks like it's disabled. Maybe the host has to enable
now
it.
You try, sir.
Is it in presentation mode now?
Yes, sir. Your screen is visible here.
Okay. Yeah, thank you so much for inviting me. Let me also thank Professor Subarna from Tribhuvan University, as well as Dr. Smice, who have invited me for this talk. Yeah, I will be giving a short note on IoT and Edge Intelligence. Of course, they have introduced a lot about me, so I'm not going to discuss much about these aspects here. Let me quickly jump into the topic. So basically, I will start with IoT basics, then I will explain the framework of IoT. Then the edge, as well as highlight few of the research directions that focuses more towards TensorflowLite. In fact, IoT is keeping on booming, right? It's the trend is almost booming all the time. If you see the IoT, it is basically an extension of internet, right? It's termed like future internet, where trillions of sensors, digitized objects are about to get connected in the near future. Earlier, we were just seeing like the devices or computing nodes, mobile phones will get internet. But now, we are trying to see, or we are going to connect to things. It could be like fan, lights, table, chairs, and so on. So any objects may get internet in the future. So it's having a lot of benefits, a lot of potential developments are possible, and that's the reason. Like in entrepreneurs as well as business people, also the technical aspirants are finding it more interesting. Like you can see it has a large potential to keep the society more smarter. Right, in 2050s, it is expected that human life will have lots of interactions with robots. You can have some sort of helmets which will turn you back to older age, and you can visualize what's happening in the past. You can also get a partner with devices. Not biologically, but you get the best behavioral characteristics that will match to you. Small flavors are already up in the market, like voice assistants, right? You can talk to the Alexa or Siri, and it talks with you, make fun with you, right? You have the better connections, feelings, and so on. So this is the stepping stone that make you more productive. Also, the society is going to be more knowledge driven. Like when we say the devices are getting connected, right? All the devices, like in and around you, around the 10, 15 sensors are communicating each other, and they are trying to give you the best ideas or knowledge, like you have to follow this, you should not do this now, and so on, which will definitely keep you more productive, right? The machines will communicate each other, right? So mostly like the machines from industries, machines from smart vehicles, they all are going to communicate each other. They provide the best solutions. So almost many devices, therefore, when it gets connected, you can see very good knowledge in the future. So it's in a very nutshell, it's an extension of internet, right? The devices get more powerful enough. The trends are also keeping on increasing, right? Mobile devices, sensor embedded devices, right? Microcontrollers with sensors that are talking directly to the internet through Wi-Fi modules or some Bluetooth and so on. IEEE 802.15.4 standards are followed, Zigbee devices. So many devices, when they get connected, there are so many potential growth, and you can see the growth factors, right? This was taken in the early 2020s, but it should reach here at the moment, and you can see the patenting structure also. You can see a lot of investment also happening in this particular field. Right, it is the revenue. It is also expected to reach $1.5 trillion, which is which shows that there is large potential. But today's talk, I'm going to explain that IoT, when it merges with sustainable computing or mobile other technologies, there is a huge potential of revenue in the future. Smart cities, right? Connected industries, connected building, connected car, smart energy, connected health. Everywhere, the intelligence play a major role with the help of these devices, right? The sensor nodes with powered with intelligence, right? It has a lot of potential to grow. Say a smart city official need not go to the particular location to get the information right in his desk. It can happen through the embedded devices that are spread across distributed geographically, and you can power in, right, the potential of these devices. Yeah, industry-wise, if you see, there's still a lot of patents are still on progress. So, having seen that IoT definitely will create more traction in the future, let us start with the very basics, and then I will move on to the toughest research topics that happen in this particular field. So, in very generic principle, we see that IoT consists of sensors, actuators, as well as network devices. Sensors, which is going to sense particular parameters like temperature, light, humidity, and so on. And based on the sensing information, the system, the IoT application should perform some sort of intelligence. Where it can perform this intelligence, it could happen in the network devices, right? The network devices could be in the cloud, the fog, edge, and so on. And then based on the intelligence, the action should happen. So actuators are kind of devices that make some action or preferably used. So traditionally, things happen in cloud, right? Things happen in cloud. So I told like sensors, actuators, as well as the network devices. These are the three major components that are there. When we say that the sensors, the sensor data is processed somewhere in the network, right? It could be processed in edge, fog, or cloud. These are different, computing capable devices, right? Environments that offer computing. So when the intelligence, it has to be processed. It's recent years we can see like many of the applications are also falling in this computer vision domain. Like you take you develop some sort of small devices which will have a little camera and say for example like ESP32 microcontroller will be there with ESP loaded in it, right? You will have a camera attached to it. You can carry the camera directly near to the object or for example image classification problems. You want to show it to the objects or like for example fruits or for example animals, and immediately want to see what's happening. Or a person carrying a mobile device to their tourist place, right? He has to take some pictures, and immediately based on the pictures, he has to see what's that, right? What happens there? What is this picture all about? And with all histories, he has to get the information. Or he may want to get the information like what was the this particular scenery like 10 years back or 5 years back, or what was the scenario, what would be the scenario 10 years later in the same location, just by capturing this in the mobile or some small embedded devices. So sensors is sensing something, it's capturing, and then intelligence should happen in the networked devices, and then the outcome, right? Stating like what would be the what would happen, or should we create some alarms? So these all things should process in this particular IoT application. So these days, intelligence is very, very important, crucial, and unavoidable, right? So you could observe that lots of publications and works are in the field of deep learning, right? Which is just an ML technique that learns features, like images, from the images, audio, text. A few example, like a simple example like Google Lens, right? You can see, you capture the image and immediately you see what is this, right? So underneath all this intelligence play there, right? So the deep learning models are also incorporated into the IoT related applications, right? So why people go for such robust models? Because it's robust, accurate, getting more accurate, right? You can have powerful devices which can speed up the executions and see what is to happen, right? And these days you can also see lots of data sets, like even our group created facial emotion data set exclusively for India, right? So likewise, many research groups are creating very good data sets that are very useful for learning and making the learning process to happen, right? And so many good algorithms are up. So in many fields, right? Many fields, machines are allowed to talk, and machines are allowed to make the intelligence to perform as like humans, which is still to realize to the 100% level. The steps are on progress, right? Embedded devices are supportive enough, right? Like smart healthcare, smart home security, smart cargo handling, smart traffic management. Many fields. You can see that intelligence intelligence is playing a major role. And if you see traditionally what was happening, the data was just sent to cloud. The cloud will do the processing, right? You take the picture in the camera, and the image is transferred to the cloud. The cloud makes the analysis, like what it has to, what is this location, what is this all about, right? Even if it's image classification, right? You want to capture the image, and the processing happens in the cloud, right? Or this deep learning algorithm, implementing this deep learning algorithm, analyzing them, all happened in cloud. Of course, it's scalable. Data is accessible everywhere. And cost effectiveness is also perfectly okay. I will talk about this cost effectiveness even further when I discuss about the next architecture. So in general, cloud was there, and you can see, like, you will have to pay for storage as well as computation. The real importance comes with edge intelligence, right? So the embedded devices should become more powerful enough, right? It is not possible for certain reasons, right? For certain reasons, like edge, which is the computing part, which is very near to the sensors, right? The edge nodes are typically used for computations rather than sending the sensed data directly to the cloud for several reasons, because sensors could have a lot of data. Imagine you're capturing the image from camera. All the images, video footprints should go to the cloud for doing the intelligence or performing the algorithm, right? The network bandwidth obviously will take more. Also, the response time. So if the processing should happen in the cloud, right? And then if the action should happen, or some response we should see in the sensor device, the response time will be very high, right? Also, some people will not be interested to send their photo, right, pictures to the cloud to do the processing, because it is third-party device, right? So they are not willing to do that. So how can we process this local data in your place itself? So you need to have some solution for this. Therefore, edge intelligence, the intelligence performing the edge, is the best option. So luckily, there are a few platforms already available to do the intelligence in cloud normally, like PyTorch, TensorFlow related platforms are already available. Google has Google Colab. Several providers, they develop their own platforms that will provide you such setup. But if it is mobile, right, embedded based intelligence which you want to perform in the edge node, TensorflowLite provides this, right? So the learning is now happening in the edge node, right? The embedded node, like ESP32, or a little bit more powerful like the Jetson Nano, or Spark Fund, such kind of boards, right? You can use them for performing this, and also you can see like learning or creating this learning models is typically very, very large and time consuming, right? So you have to spend a lot of hours to get the inference of this, which is typically very nearly impossible with embedded devices. Your mobile phones then are the microcontrollers of smaller range with a little data rate. It is not really possible to do that. So TensorflowLite helps in doing this. How? Most of the learning will already happen in cloud, and the model alone is transferred to the embedded device, and then with the data set that you have, you can get the inference of what you want to get in the edge device, right? So it's very simple. With now no setup is very, very simple enough. Like you can develop the model in cloud. You can just convert the model that is suitable for the embedded devices, deploy that. So in TensorflowLite, it is like TF-Lite file, okay, with certain checkpoints. Then you can deploy this model to embedded devices, optimize and run, right? So these are some of the steps, and also very particularly a teachable ML platform is recently available. Engineers or smart people are not even requiring coding, right? So you just want to feed it the images for which you want to use. Like for example, a tourism location is there. You just take a lot of pictures of the tourism, then show that tourism images, upload them to this teachable ML, and you get the TF-Lite. Load the TF-Lite to the embedded devices, microcontrollers, for example, and then by just taking the picture, you are able to get the classification, right? A simple subset of IoT-based examples, right? So you can develop, developing models could be like audio samples, classifying images, and so on. You can this is how the screenshots look like. Okay, I'm just showing you the screenshots. Another important point which we have to see here is, even though we perform intelligence in edge nodes, okay, right, with TensorflowLite or whatever, remember I was mentioning the cost involved in cloud, even though it is efficient, it is not really much efficient because you are powering on the EC2 instance all the time. Okay, if you have written an IoT application in cloud, and if you have implemented the intelligence, most of the intelligence in edge, you still have to power on this cloud instance all the time, which is like you are going to pay 24/7 for the IoT application for what you have used. In this case, if you are using the traditional way of cloud execution, you will be paying for the EC2 instance throughout this period. Not only the computation cost EC2 instance, you will also pay for the storage, right? So you are paying, and therefore, even though we told like cloud is cost efficient, still it is not really very cost efficient. So I propose that we should use serverless. Okay, in serverless, the devices are not powered on in cloud. Okay, you are using it only when the request or the trigger comes from the bottom level. So since we are doing most of the intelligence in the edge and doing the processing in the edge, there is no need of all the time no resource in the cloud. So only when it is really needed, you are just you need to power on this machine and you want to use that. So serverless IoT will provide this feature where you can even go beyond your expectation of optimizing the resources. Right. In fact, there are a few performance issues which I have listed here. When you want to mainly talk about this cold as well as warm start due to time limitation, I'm just hurrying here. But one of the important problem which we can see here is to identify, should we use this resource in cloud, should we use fog resource or should we use edge resource, and to which extent we want to use them, right? It's a mapping problem, right? Which computing resource to use so that we get the near optimal solution. Quantum computing is also a topic of research in this field. People like to immediately see the mapping done in very short span of time. So quantum computing, which is also popping up these days, you can use this quantum algorithms to find the best map of using cloud or edge or fog or computing instances to a certain extent, right? So in quantum, it's the representation of the states are not 1 or 0, it is 1 and 0. This means you can see all the solutions or all the parts of your combination in one stretch itself, right? So people discussing about IoT in edge intelligence for an IoT framework is trying to find a solution that will offer this outcome, right? Should we use cloud? Should we use fog? Should we use edge? Or which resource of cloud should we use? Which resource of fog we should use? Which resource of edge we should use when we do the edge intelligence? So for this, to study the mapping, you can bring the normal classical computer input to the quantum computers, and instead of doing the normally in search algorithms, we go one after the other, find the optimal or suboptimal solution, and then we select one of those and we fix to them. But in this case, we can use the quantum computers, which will show you in one stretch. Of course, there are some other research problems here, which I need not discuss now. So you get the outcome of what configuration should we use, and then we are done, right? So the major research thoughts, what I want to highlight here in this talk is definitely we need to apply edge intelligence for IoT-based applications where embedded devices, mobile devices are used. Battery optimization is very, very important constraint here, as well as security becomes, privacy of the data becomes an important concern here. So research thoughts are more taken here. You can use serverless because we say that we have to create the IoT framework that is more and more cost efficient, as well as energy efficient. So serverless will play a major role. Finding out which devices, which configurations, or which solution we want to choose, we could go for best algorithms. Very recent ones are with quantum, application of quantum computers there. So we can think about in that direction. So I am almost at the end of the lecture talk. The citations which you may be of interest are shown here. And also I would like to highlight there are 2 incubation centers at our center. you can visit us, and also keep in touch if any important things are relating to this IoT is of interest to you. Thank you so much.
Thank you, Dr. Shajulin.
Thank you, sir. We'd like to acknowledge our gratitude to Dr. Shajulin Benedict, sir, for exposing his theory of IoT and edge intelligence. We are all inspired by your great words. Thank you, sir.